VLSM Practice. In this video, we're going to take everything that we learned from the previous video and I put it into practice. So there are a series of variable length sum masking questions. There's going to be 5 in total that I want you guys to go through first, and then play the video once you've gone through each question. So let's dive straight in. So question 1. Which of the following options are examples of variable length sum masking? Pause the video, have a go at the question, and then resume play of the video once you've had a go and you think you've got the right answer. So I've assumed that you've paused the video and had a go at the question. And so with this question, there are 3 correct answers to this question. This asks us which of the following options are examples of variable length sum masking. And with variable length sum masking, we start off with a classful network. Let's say 10.0.0.0/8, and then we subnet that and create subnets which are of different lengths. So we may have some /23s running around, some /24s, some /30s, which is different to fixed length sum masking. So with fixed length sum masking, we have one subnet mark which is used throughout our enterprise network. With variable length sum masking, we have different subnet masks used. And so if we look at variable length sum masking from this point of view, the correct answers are number 1. So question 1, so then it's 1, 3. So tick 1, tick 3, and 4. So the reason why 1, 3, and 4 are correct is because if you look at 1, we're subnetting a subnet of a class C address. So the way that I look at this is that we're creating a subnet of a class C subnet, which means that we're going to have more than one subnet mask used throughout our enterprise network, making this an example of variable length subnet masking. Just to contrast that with another example, with this one, we're taking a class C address which hasn't been subnetted at all, and we're subnetting it into multiple /29s. That just sounds like fixed length subnet masking to me, because we don't have multiple subnet masks throughout our enterprise network. So 1, 3, and 4 are correct, because what we're doing, we're subnetting subnets of a classful network, meaning that we're actually doing variable length subnet masking, because we have subnets and subnet masks of different sizes throughout our network. So if you got 1, 3, and 4 as your answers, then you are correct. Those are the correct answers. And so this is kind of like a trick question, the question that you might see in the exam as well, in that you have to look at variable length subnet masking in this context, that we started with a classful network and then we create multiple subnets of that single class A, B, or C address. So as an example, with answer 5 is that we're taking a /16 and we're going to subnet it into multiple /24s. That just sounds like we're going to use a single subnet mask throughout our enterprise, which doesn't make that variable length subnet masking. But with answer 2, with example, with answer 3, we've taken a /16, we've subnetted it down into a /24, and then we're creating /26s from that /24, meaning that we're actually doing variable length subnet masking. So 1, 3, and 4 are correct. Question 2. Variable length subnet masking is used throughout this network. Use the address provided and assign an IP subnet to each segment shown below. So again, pause the video, try and work through this question yourself, and then once you've finished, play the video and I'll go through my answer. So welcome back. I've assumed that you've had a go at this question. And so this question really go through everything that we covered in the previous video. So in the previous video, I showed you the process that we can use in order to variable length subnet mask a enterprise network once you're given a topology or a diagram like this. So the first thing that you should have done would be to organize these subnets in order of size. So list the largest segment first, then the next largest segment, then the next largest segment, going down all the way to the 2 smallest segments. And then after that, we need to work out how many host bits we need in order to provide addressing for each segment. So in this case, we just go up in powers of 2 until we get to a number which is greater than the number of hosts we need, or equal to the number of hosts we need. So as an example, 2 to the power of 1 is 2, 2 to the power of 2 is 4, 2 to the power of 3 is 8, 2 to the power of 4 is 16, 2 to the power of 5 is 32, 2 to the power of 6 is 64, 2 to the power of 7 is 128, 2 to the power of 8 is 256, and 2 to the power of 9 is 512. So from these calculations, I can see that we need to have 9 host bits in order to provide addressing for our largest subnet. So I'll write 9 host bits. We're going to need to have at least 8 host bits to provide addressing for the next largest segment. 8 host bits. We're going to need to have at least so 60, 1, 2, 3, 4, 5, 6. We're going to have like 6 host bits to provide addressing for the third largest segment, and then we're going to need to have at least 2 host bits in order to provide addressing for our WAN links. 2 host bits, 2 host bits. Now, in order to find out what the subnet mask is going to be, all we do is subtract the number of host bits we need from 32. The reason why, the 32 bits in a subnet mask, we know the 9 bits are going to be binary zeros because as an example, for the first segment, which needs at least 9 host bits, we know the 9 bits are going to be reserved in the subnet mask for the host part, which means they're going to be all zeros. Which means to find out how many binary ones we have, we just do 32 minus number of host bits, and the answer we get would be the number of binary ones we're going to have in our subnet mask. So in this case, 32. I'll do up here actually. So 32 minus 9 equals 23. 32 minus A equals 24. 32 minus 6 equals, so to take away 4 is 26. Then again 32 minus 2 is just 30, and over here 32 minus 2 equals 30. So now that I've looked at the number of host bits I've got, before I do anything else, I just want to work out the range of addresses available to us with this subnet of a class of network we have. So in this case, we're assigned address block 172.16.0.0/22. So let's convert the slash mask into its decimal format. So first octet is 8 binary ones, followed by 8 binary ones, followed by 6 binary ones. So 6 binary ones is 192.224.242.248, 252.0. Now to work at increment, we do 256 minus 252, which gives us 4. And so the address ranges we have is from 172.16.0.0. The next one would be 172.16.4.0. So address ranges we have would be 172.16.0.0 through 172.16.3.255. So we're assigned this subnet of a class B address. The reason why I worked out what the next subnet ID would be, so that I could work out my range of addresses, because we know the range of addresses would be from this subnet ID to the broadcast address, and to calculate the broadcast address, it would be the IP address before the next subnet ID. So we can remove that. So that's our range of addresses. Now, for each segment, let's calculate the list of subnets, the list of potential subnets we could have for each segment based on the subnet mask that we're given for each segment. So in this case, let's calculate the subnet IDs for the /23. So we know we have 172.16.0.0. /23, there'll be in decimal, that's 255.255. So 8 binary ones, 16 binary ones, followed by 7 binary ones. To find out what 7 binary ones is in decimal, what we do is write down our 8 value table. So 128, 192, 224, 240, 248, 252, 254, and then 255. So when we have 1, 2, 3, 4, 5, 6, 7 binary ones in a subnet mask octet, that means that the decimal equivalent would be 254. 0. That means that the increment's going to be 2. So we do so we do 256 minus 254, which gives us 2. So increment's going to be 2. Now that we've done that, let's calculate the next subnet, 172.16.2.0/23, and then 172.16.4.0/23. Now, out of all these subnets, only the first two are viable subnets that we could assign to this segment over here. The reason why, because they fall within the range of IP addresses that are allocated to us. This is why it's very important that we work at the range of addresses that have been allocated to us, so we can see which subnets out of our list are viable to assign to the segment. And in this case, we're just going to assign this guy the first IP subnet, which has an address range from 172.16.0.0 through 172.16.1.255. Yes, that's going to be our, let's get rid of this one, it's going to be our subnet. Now, let's work out the range of the different subnets for this /24 mask, which in decimal, this should be easy for us, is 24 binary ones, which is 8 binary ones followed by 8 binary ones followed by another 8 binary ones, which is a standard mask of 255.255.255.0. Now the available subnets: 172.16.0.0/24, 172.16.1.0/24, and then 172.16.2.0/24, 172.16.3.0/24, and 172.16.4.0/24. Now, of all of these, the viable subnets would be the first 4. So these are subnets that we could potentially assign to that segment. And out of these 4, the ones that we could actually assign to that segment would be one of these two. The reason why, because these first 2 subnets, the range of addresses covered by these first 2 subnets falls within the range of addresses covered by this subnet. So if I assigned either of these 2 subnets to this segment over here, it means we're going to have overlapping IP addresses, which would cause problems with routing. So I'm going to assign this third segment, this third subnet, to that segment. And as you can see, this subnet over here that I'm going to assign to that segment, the subnet ID is the same as the subnet ID for the second /23 subnet. So normally, if we do variable and subnet masking right, and we do it with this process, you'll notice that the next subnet that the subnet that we're going to assign to the next segment would just be the subnet ID. Hard to explain. So like with this, the subnet ID that we're going to assign to this segment over here is the same, has the same subnet ID as the next subnet in line after the first subnet that we've assigned to this segment over here. So as you can see, the first subnet for /23 is 172.16.0/23. Then the next subnet in line for /23 is 172.16.2.0. The subnet that we're going to assign to this segment over here is 172.6 is the third subnet, which has a subnet ID of 172.16.2.0/24. So it's the next subnet in line, and you'll notice that when we do variable and subnet masking right, this is going to be the case. So I'm just going to remove this one, we don't need it. Now let's work out the range of addresses available for /26, or the subnet, sorry, the subnets available for /26. /26 is 8 binary ones followed by 8 binary ones followed by 8 binary ones. That gives us 24 binary ones followed by 2 binary ones, which is a 192. The increment is going to be 256 minus 192, which gives us 64. Okay. Let's start listing the subnets in line. So we got 172.16.0.0 slash 26. Then 172.16.0.64 slash 26. Then 172.16.0.0 slash 128 slash 26. Then 172.16.0.192 slash 26. Then 172.16, so we have 64 to this, that will give us 256, which means we're going to carry the 1 and 0 slash 26. So as you can see, instead of me going down, because we've ordered our subnets from largest, or our segments from largest to smallest, that means the next available subnet that I can assign to this 60 host segment over here should be a slash 26, which begins with this subnet ID. And so if I was to continue going down, I get up to the point where I reach this subnet 172.16.3.0/26, then 172.16.3.64/26. So I'm just going to remove all of these quickly. Leave this. So I'm going to assign this subnet to the segment with 60 hosts. Now we're going to work out what subnet we can assign to our WAN links. So what we do is, we know that's a slash 30 mask. It's going to be 255.255.255, 6 host subnet bits in the last octet. So 1, 2, 3, 4, 5, 6, which is a 252. Gives an increment of 4. So 256 minus 252 equals 4. That's going to be increment. Start off with 172.16.0.0/30. Then 172.16.0.4/30. So I could continue to increment, but we know that it goes up in multiples of 4. So can we make 60? So is 64 a multiple of 4? So we've got 40, 44, 48, 52, 56, 60, 64 it is. So my thinking here is this: there's no point in me going through each and every subnet, because I know that I'm going to get to the point where I'm at 172.16.1.0, then 172.16.2.0, then 172.16.3.0. I would, because it's going to be the last octet incrementing, I would find out whether 64 is a multiple of 4. So we got 4 times 10 is 40, 44, 48, 52, 56, 60, 64. 64 is indeed a multiple of 4. So that means that the next subnet I can assign to one of the WAN links would be a subnet with this subnet ID over here, but instead of having a slash 26 mask, it'll have a slash 30. 172.16.3.64/30. Then 172.16.3.68/30. And so this would be assigned to one WAN link, and this would be assigned to the other WAN link. So as you can see, with VLSM masking, if you follow the process that I showed you in the previous video, and you label, and you order these segments in order from, so you list the segments in order from largest to smallest. That means though, usually once you find the subnet ID for the first segment, the subnet ID for the next largest segment is just going to be the next subnet ID in line, but with a different subnet mask. So in this case, I assign the 172.16.0.0/23 subnet to my largest segment. Then the next largest segment, which is 200 hosts, use this subnet ID, so 172.16.2.0, which is the second subnet that we can get with a slash 23 mask. However, instead of using a slash 23 mask, we just use a slash 24 mask. And then the same thing here. The next segment line for slash 24 is 172.16.3.0. And we assign that subnet to this segment with 60 hosts, but with just a slash 26 mask. Then the next segment line is 172.16.3.64. We assign that to one of the WAN links, but with a slash 30 mask. So by ordering it, so what I'm showing you now is kind of like a shortcut that we could use in the exam. And so if you do variable length standard masking properly, you order it properly, then you can use a shortcut in order to find out what the next subnet ID in line would be. So I'm going to pause the video. I'm going to quickly jot down the subnets, and then we'll move on to the next question. So welcome back. This is the so this is the answer. These are the subnets that you should have assigned to each segment. As you can see, we did have enough addresses from this /22 mask. Now let's move on to the next question. So question 3. VLSM is used throughout this network again. Use the addresses provided to us and assign an IP subnet to each segment shown below. So again, pause the video, try and work through this yourself. Then once you've finished, play the video, and then I'll show you how I work through this question. So welcome back. I've assumed that you've had a go over the question. Now I'm going to go through the process that I would follow in order to solve this question. The first thing I would do, again, is list the segments in order from biggest to smallest. So note that the largest segment is going to have 46 hosts. The next largest segment is going to have 28 hosts. And then the smallest segment is going to be our WAN link, which will have 2 hosts. Now how many bits are we going to need, host bits are we going to need, in order to provide addressing for each segment? So again, to do this, all we do, we go up in powers of 2 until we reach the correct number, which either allows for the addressing of the host, but it's larger or matches exactly. Normally, it's very rare that you get a number which matches exactly, but it's going to be the closest number to the number of hosts that we need to address. So again, 2 to the power of 1 is 2, 2 to the power of 2 is 4, 2 to the power of 3 is 8, 2 to the power of 4 is 16, 2 to the power of 4 32, and 2 to the power of 6 64. So from here, don't need to go any further. I don't need to have 6 host bits for my first segment, largest segment. I need to have 1, 2, 3, 4, 5 host bits for the next largest segment, and I'm going to need to have 2 host bits for the WAN link. 2 host bits. Now to work at the subnet masks, all I do is subtract 32. So all I do is subtract the number of host bits from 32 in order to work out how many binary ones we have in the subnet mask. So 32 minus 6 equals 26. 32 minus 5 equals 27, and 32 minus 2 equals 30. Now I need to convert those masks from slash format into the decimal equivalent. So slash 26 in decimal is going to be 255.255.255. So A 1624 binary ones, followed by 2 more binary ones, which gives us 192. Then a slash 27 is going to be 255.255.255 dot 192.224. So 3 binary ones will be 224. And a slash 30, we already know this is going to be 255.255.255 followed by 6 binary ones, which is going to be 192.224.248, 252. So 252 dot 252. Now that we've worked out all the subnet masks, let's work at the range of addresses that are provided to us with this subnet that we're given. So we're not given a whole Class A network, we're given a portion of a Class A network. Let's see the block of addresses that have been assigned to us. So again, a slash 25 in decimal is 255.255.255. 1 binary ones is going to be 128. That means the increment then be 256 minus 128, which gives us 128. That means the range of addresses that have been assigned to us are 79.211.88.0. If I add the next subnet in line would be 79.211.88.0.128. Range of addresses are from 79.211.88.0 through 79.211.88.0.128. 192.127. So there's a range of addresses that have been assigned to us from this subnet. Now we're going to work out our increments for these three subnets here. Increment here would be 256 minus 192, which gives us 64. Increment for this subnet is going to be 256 minus 224, which gives us 32. Increment over here is going to be 256 minus 252, which gives us 4. Now let's list the subnets that we can get with this subnet mask. Okay, so we have 79.211.88.0/25. Then we have 79.211.88.0, that's 88.64/25. Oh, sorry, 26, sorry, not 25, 26. Then we have 79.211.88.128/26. So as you can see, if we were doing fixed like subnet masking here, we would only have 2 subnets available to us, which means that we could only assign 2 segments subnets, and one segment would have no subnet. So this is why router subnet masking comes into use, because it allows us to have more efficient use of our IP address blocks. Now from that, I'm going to assign the first subnet to our largest segment. So yes, and like I said before, the next subnet, so the subnet that I'm going to assign to this segment over here is going to be the next subnet down, but with a different mask. So in this case, /27, it's going to be, so I'm going to assign this subnet now to this segment over here, but with a /27 mask. The next subnet in line with a /27 mask would be 79.211.88.96/27. This is going to be assigned to that segment, and like before, all I'm going to do is that to find out what /30 mask, I'm going to assign the next subnet, the next /27 subnet to this segment over here, but with a /30 mask. So in this case, it will be 79.211.88.96/30. And so it's as simple as that. Once we've ordered our subnets, our segments from largest to smallest, so the way it would work is that once we've assigned our largest segment the first available subnet, the second largest segment would just be assigned the next subnet in line, but with a different subnet mask. And so in this case, this subnet over here is assigned this subnet, but with a /27 mask. Then we list the next /27 mask that we can get, which in this case is this one over here, 79.211.88.96. Then we assign this subnet to this WAN link, but with a /30 mask. So I'm going to pause the video, label up the diagram, and I'll be back with you in a moment. Welcome back. So these are the subnets that you should have assigned to each segment. And let's move on to the fourth question. Question 4. What is the network and subnet mask of the hidden subnet? Extra. So what is the subnet mask and hidden subnet of this segment over here? The whole network has a network address and subnet mask of 192.168.0.0/23. So again, pause the video, try to go through the question yourself. Then once you've gone through the question yourself, play the video and I'll show you my answer. So I've assumed that you've attempted the question, now I'm going to go through it myself. Now, this question is slightly different from the other ones we've had. In this one, we're given the original network address and subnet mask that we're told to work with, but the segments have already been subnetted for us. So most of the segments have been assigned a subnet, and we're told to describe what subnet and subnet mask would be given to this subnet over here. The first thing I would do would be to find out the range of addresses that I have to work with this original subnet and subnet mask. So in this case, 192.168.0/0. A /23 mask in decimal is 255.255. So 8 16 binary ones followed by 7 binary ones, which is 254.0, which gives us an increment of 2. In this case, the next subnet in line would be 192.168.2.0, meaning the range of addresses we have available to us with this subnet we've been assigned is from 192.168.0.0 through 192.168.1.255. Now I'm going to work out the range of addresses covered by each subnet. So in order to do that, all I do, take the subnet it takes. So in this case, we're going to start with the largest and then work our way down. So we're going to look at this one, then this one, then this one, and then we're obviously going to look at this one last. So 192.168.0.0.25. Range of addresses covered. So 25 in decimal would be 255.255.255. So we've got 1624 binary ones followed by one more binary one, which is 128. The increment is going to be 128. The range of addresses is from 192.168.0.0 through 192.168.0.127. Now for this subnet over here, so let me just take we look at this one. For this subnet, it's using the same mask, so the range of addresses is going to be, in fact, it's using the second /25 subnet that we have available to us. The range of addresses will be from 192.168.0.128 through 192.168 dot 0.254. Then this subnet over here, so we've done this one, we're going to move on to this one over here. Subnet ID is 192.168.1.64 with a /27 mask. /27 in decimal is going to be 255.255.255 followed by 3 binary ones, which is 224. So we've got 256 minus 224 is going to be 32. So the range of addresses would be from 192.168.1.64 through 192.168.1. The next subnet in line would be 96, meaning that the broadcast address for this time is going to be one less than that, which should be 95. As you can see over here, the WAN link is assigned the next subnet available to us, so 192.168.1.96/30, and range of addresses would just be from 192.168.1.96 through 192.168.1.99. So we've got 97, 98 assignable, 96 and 99 are reserved. So from the way I'm looking at it, we can see that this segment over here, so we've done this segment and this segment, is going to be the third largest segment, which means the address range or the subnet assigned to it should fall within 192.168.1.0 through 192.168.1.64. So 58 hosts of that's how big this segment is. How many host bits am I going to need to borrow in order to address 58 hosts? So again, 2 to the power of 1 is 2, 2 to the power of 2 is 4, 2 to the power of 3 is 8, 2 to the power of 4 is 16, 2 to the power of 4 is 32, 2 to the power of 4 is 64. So I need to have 1, 2, 3, 4, 5, 6 host bits, which gives me a /26 mask. So now we know the mask. So 26 in binary is going to, in decimal store, it's going to be 255.255.255. 2 binary ones, which is 192, which gives us an increment of 26 minus 192 equals 64. Let's start to list the subnets available to us. 192.168.0 dot 0 slash 26, then 192.168 dot 0 dot 64 slash 26, then 192.168 dot 0 dot 128 slash 26, then 192.168 dot 0 slash 192 slash 26, and finally 192.168.1.0 slash 26. So from here, I can see these first 4 subnets are not going to be available because the range of the addresses covered in these subnets is covered in these 2 subnets that we've assigned to these segments over here. It's going to be this subnet. And so if I was going to work this out, all I would just do, because we know that this segment is the 3rd largest, means it's going to fall between these 2, I would look at the subnets covered in this segment and in this segment, and I know from previous questions that this segment over here is going to be assigned the next slash 25 subnet, but was a slash 26 mask. So in this case, the next slash 25 subnet is going to be 192.168.1.0/25. So that's going to be the next slash 25 subnet in line. I'm going to assign that subnet to this segment, but was a slash 26 mask. And if you think about it, then the next slash 26 subnet over here is 192.168.1.64/26. That subnet ID has been assigned to this segment, but was a slash 27 mask. So the correct answer is 192.168.1.0/26, which has been assigned to this subnet over here. And so if you got the answer, then you're correct. Just to complete it, 192.168.1.0/26. That's the subnet ID and subnet mask of the hidden subnet. Now let's move on to the 5th and final question. Question 5. We have a network with the following requirements. HR has 200 hosts, has 20 hosts, IT has 500 hosts, accounting has 300 hosts, and sales has 10 hosts. VLSM, so variable length subnet masking, is used throughout our network. What network meets the requirements whilst waiting the least addresses? So this is saying we're not being asked to perform variable length subnet masking. We're saying that given this network to begin with, could we variable length subnet mask this network in order to meet the requirements of this network over here? So we're not saying we're going to variable length subnet mask this. We're saying that which network can we use to perform variable length subnet mask to meet these requirements. Again, pause the video, work through the question yourself, and then play the video to see my answer. Welcome back. So I've assumed that you've attempted the question, and I'm going to work through it myself. The first thing I would do, before I even look at the answers, I would work out how many host bits I'm going to need in order to provide addressing for each subnet. So for each department, so I know I've got 1, 2, 3, 4 departments. That means I'm going to have 4 different subnets, and I'm going to look at each subnet individually. Just like before, I'm going to label the subnets or list the segments from largest to smallest. So in this case, 500, then 300, then 20, and then 10. How many host bits I'm going to need to provide addressing for each segment? So in this case, we'll count up in powers of 2 until we get to the correct numbers. 2 to the power of 1 is 2, 2 to the power of 2 is 4, 2 to the power of 4 is 16, no, it's 8, sorry, that's 2 to the power of 3 is 8, 2 to the power of 4 is 16, 2 to the power of 5 32, 2 to the power of 6 64, 2 to the power of 7 is 128, 2 to the power of 8 is 256, and 2 to the power of 9, no, 2 to the power of 9 is 512. Okay, so from here, I'm going to need to have at least 9 bits for the host part. I need to have at least, again, another 9 bits for this segment over here. I need to have 9 bits. From here, I'm going to need to have 5 bits for this segment, and I'm going to need to have at least 4 host bits for this segment. 4 host bits. Okay. So that's going to be list the numbers in binary available. The number of addresses we're allowed to address in binary: 512, 512. Then we go 5 is going to be 32, and then 32. Sorry, 16. So we've done that. That's all done. Now, instead of working out, instead of trying to subnet each answer individually, we know we're going to need to. So before I do that, before I describe anything, I'm just going to add these numbers together. So again, so 512 plus 512 equals 1024. 32 plus 16 equals 48. If we do 1024 plus 48, what does that give us? Plus 48. That gives us, so that'd be 1064 plus 8, then be 1072. So before we do anything, before we even subnet or anything, we know that the original network that we're going to begin with has to have at least enough host bits to address 1072 host devices. And the reason why is because that's how many host bits, so that's how many host addresses that we're going to use up with our different subnets. So we know now that any answer we're going to choose, we need to have at least 1072 host addresses available to us before we even subnet, so that we know that we can create enough subnets for each segment, and then we can have enough hosts in each segment, or have enough hosts in each subnet. So having that in mind, the first answer has got 8 host bits, which gives us 256 hosts, which means that it won't meet our requirements of 1072. The next answer has got 9 host bits, which gives us 512. The fourth answer has got 10 host bits, which gives us 1024, which still isn't enough. And the third answer, we have 11 host bits, which gives us 2048 available host addresses, meets our requirements. So number 3 is the answer. So again, this is another shortcut that you can use. So my thinking here is that I know I'm going to need to at least have 1072 host addresses for me to create subnets of each segment and have the subnets at the correct size. Now, because we're borrowing host bits, because we're borrowing bits from the host part to create our subnets, I know that I'm going to need to have the correct amount of host bits in order to create the correct amount of subnets at the correct size. So because I know that I'm going to need to have at least 1072 addresses, instead of working through each subnet, why don't I just look at how many host addresses are given to us by the original network before I choose which network would be most suitable. And as you can see, the only network, or the only subnet that gives us enough addresses to work with is this one over here. The first one gives us 256, which isn't enough. The second one, 512. The third one, 1024. But it's the third one, the third answer, which gives us 2048 host addresses to work with, which is more than enough to meet our requirements. So answer 3 is the correct answer to this question. So we have reached the end of this video, and we've gone through 5 questions, 5 variable length subnet masking questions. Again, like with fixed length subnet masking, there are a few shortcuts that we can use to make it easier. I've shown you those shortcuts in this video. If I was you guys, I would try and do as much subnetting as you can, so you become very good at it and become very, very fast at it. Look online, read books, even create your own variable length subnet masking questions like I've done, in order to get practice. I hope this has been informative for you, and I would like to thank you for viewing.